especially related with energy, zero energy building. I think the topic that will be delivered by Professor join us in this session. So I hope that there will be a lot of things that we could learn from Professor Tsutsumi, and we will open a question and discussion session at the end of the presentation by Professor Tsutsumi. I hope that some of you could give some questions or comments for Professor Tsutsumi. Okay, once again, thank you to Professor Tsutsumi. And please, Professor Tsutsumi, you can start your sharing your presentation right now. Thank you.
Okay, thank you, Dr. Edward. I appreciate your organizing ability to make
Yeah. I'm sorry for the scheduling today.
I misunderstood that I got the new access point for the Zoom meeting or something.
Yeah. It's okay. Yeah.
After 20 minutes. So thank you so much, and I'm sorry to be late to start my presentation. Okay. Hello, everyone. Thank you very much for your attending. Okay. Today's topic, that is zero energy building. We call it ZEB. So I will change the display to the presentation file. Yeah. So the backside of this slide, it's not a real ZEB, but you can see the lot of the photovoltaic panels on the rooftop in the some parts of the wall. So now we are facing to the very big crisis of the climate change. And I have to touch a little bit about the climate change at first. This is the background of the ZEB. So as you know, that the biggest cause of the climate change is the greenhouse effect. As you know that the greenhouses look like this, the glass windows or roofs, it can accept the solar radiation, but long wave radiation like infrared, the glass pane stop the long wave radiation here. So that's why the energy is stuck inside of the house. The same thing happened in the surface of the earth. So normally we are thinking of the greenhouse effect all over the atmospheric layer. However, we have to understand that only the greenhouse effect occurred in the lowest laminar of the atmosphere. It's about 10 kilometers. That is called troposphere. Troposphere is a normal air. I mean that we can breathe. Of course, the higher point is very thin, but almost the same contents of the atmosphere. Over there, stratosphere and the mesosphere are gradually changing the contents of the air, and over the 100 kilometer, that is called space. So understand please that the warmed layer is the bottom layer of the atmosphere up to about 10 kilometers. Actually, the lower latitude, it's thick because of the rotation of the earth. And the Arctic or Antarctic circle, it's very thin. So anyway, about 10 kilometers, it's very thin film of the atmosphere. And normally that very thin film of atmosphere, the radiation is changing gradually. At first, I will show you the third slide. So the solar radiation coming into the atmosphere of the Earth, looks like this line. It's the bottom of the atmosphere. We can get the solar radiation on the ground surface or sea surface. It looks like this. And out of the atmosphere, it is the thick line like this. And the broken line shows the black body irradiance at the 5,800 K. So normally we can get the solar radiation like this line. So it looks like something, one peak. That is the visible light. And the longer wave is called infrared. A shorter light is called ultraviolet. And over 3 micrometer or something, the glass is opaque. So opaque means the glass cannot pass the light, infrared light anymore. So it can capture the infrared radiation. And also the greenhouse gas is absorbing the infrared radiation over 3 micrometers. These are captured in this layer. And several parts of the solar radiation is absorbed here and there. That is absorbed by the water vapor. So back to the second slide. Please understand, this is the surface line of the globe, and solar radiation is coming directly on the globe. And some lights are reflected to the space. The yellow arrow shows the shortwave radiation, almost visible light, or a shorter length of the infrared radiation. And also the sky radiation is scattering in the sky. Sky means the atmosphere. So that's why the sky is bright blue, and we can see the light everywhere in the sky. But if we have no atmosphere on the Earth, the space, space is dark, and we can see the stars even in the daylight. Anyway, the radiation of the sun is coming like this and reflected like this. And also the atmospheric radiation. This is the long wave radiation from the air itself. Atmosphere is emitting the long wave radiation too on the Earth. And of course, the Earth itself is emitting the long wave radiation too. This is the infrared radiation over 3 micrometer wavelength. And if there are a lot of the greenhouse gas, the gases are absorbing the long wave radiation here and there. This is the greenhouse effect. We need the greenhouse effect on the Earth, because if the no greenhouse effect in the atmosphere, the Earth's surface is chilled, cooled up to -18 degrees or so. We cannot live on the Earth anymore. However, the little bit of the thick greenhouse gas, it's warm too much. This is the climate change. So we have to look back the history of energy right now. And so next slide, we can understand it very well. Before the electric, so we are using the firewood or charcoal or something. And after the late of 18th century or 19th century, many types of the fossil fuel are used to generate the power or something. And normally, electricity is used for the light or house appliances like a rice cooker or washing machine, refrigerator or something. And recently, it is used for the computer or mobile phone. And also, the gases are supplied for the hot water supply or cooking. And if we look back the history of energy, so industrial revolution, that is introduced coal to the ordinary life or industrial factory or power. And that is in 19th century, electric power generation and supply or gas supply started. At the same time, the electric power is generated by hydropower. In the early 20th century, the gasoline engine or diesel fuel, that is internal combustion engine, was invested and used for the automobiles, ships or something like that. In 1950s, we can utilize the liquidized natural gas, LNG. Japan is the biggest country to import LNG, especially from Indonesia and also from Australia or something. And the nuclear power plant is started in 1950s too. However, the oil crisis started in 1973, and also it occurred in 1979. Before the oil crisis, the price of oil is very, very cheap. So it can utilize very easily, and we used oil very much. Right now, the oil prices is moving, and sometimes it is for the something like a financial system. But in 1970s, that was comes from the Iran or Middle Eastern countries. They want to make much money by oil. But it's only the economical problem. At that time, the Japan or some other Western countries are making a new energy technology that is called natural energy. For example, solar power, wind turbines, geothermal, and energy saving system is also invested. High efficiency or high performance of the energy generator or something. And gradually it is changing. So 1990s, as you know, the climate change started. IPCC is started in 1992 or 93. We have to start to think about the renewable energy again. But it's from the environmental viewpoint. 1970s, it's only the economic viewpoint. The purpose of the renewable energy was changed. We have to think about environment at first. Because of the fossil fuel consumption, we got a lot of the carbon dioxide in the atmosphere. This is the record of the carbon dioxide concentration in the world. especially this is the Antarctic Circle, Antarctic place, and we can pick up the ice sheet of the Antarctic Circle. It contains the very old atmosphere inside of the ice. So if we analyze the contents of the old atmosphere, we can get the information about the concentration of carbon dioxide inside. So about 400,000 years ago, this is moving like this from 200 ppm to 300 ppm. It's something like ice age and warm age. Sorry, ice age is a higher concentration, and warm age is not a lower concentration, because a lot of the plants are growing, especially trees are absorbing carbon dioxide. That's why the concentration of carbon dioxide is lower than ice age. So nearly 1,000 years ago, the concentration of carbon dioxide is not so greatly changed. It's about 280 ppm. But after industrial revolution in 18th or 19th century, the concentration is jump up over 300 ppm. And the recent movement looks like this. Every year, the concentration of carbon dioxide in the atmosphere is increasing by 2 or 3 ppm. And the seasonal change of the carbon dioxide is like this. So normally in May or June, the higher concentration is observed. And in September or October, the lower concentration is observed, because normally the northern hemisphere had a lot of the trees, and it is absorbing the carbon dioxide in the spring season in northern hemisphere. So leaves or grasses are growing. They are absorbing the carbon dioxide. And in the autumn season, in the northern hemisphere, the leaves or grasses are dying and change to be carbon dioxide again. So that's why this moving is observed. Of course, the southern hemisphere is moving entirely different way, but the area of the continent of northern hemisphere is much bigger than southern hemisphere. That's why the motion, the fluctuation of the carbon dioxide looks like this. Also, we are measuring the carbon dioxide concentration in Japan. It's almost the same moving. So we are measuring carbon dioxide. One is here, and one is in Okinawa, and another one is just middle of the Pacific Ocean. These 3 points are almost the same moving. So now we have to understand that the greenhouse gas, that is carbon dioxide, about totally 94% of the total greenhouse gas consists of carbon dioxide. And other gases of the greenhouse gas, that is methane, something oxygen to nitrogen, or hydrofluorocarbons or perfluorocarbons or something like that. It's totally 6%. And artificial carbon dioxide emission, it comes from the fossil fuel, about 90%. So totally, the 85% of the total greenhouse gas comes from the fossil fuel consumption. That is the effect, cause of the greenhouse effect. And the greenhouse effect makes the global climate change. That's why we have to call the greenhouse gas and fossil fuel is the main reason of the climate change. And the problem of the climate change is also the problem of the energy. The effect of the climate change is like this. It's a long-term impact on the Earth. It is called global warming. So average air temperature on the surface of the globe is gradually rising like this. The point zero, it's not a 0 degree, but it is something like average point. And if the average is lower than average point, it's negative value, and higher than the average point, it is positive value. So average point 0 means 30 years average of total data. 30 years is normally used for the something, what do you say, standard value of the meteorological data. That is defined by the WMO, World Meteorological Organization. And the short-term effect of the climate change appeared like this. It's a flood in Doha, 1918. That is about 2 years ago. So it's almost desert country, Qatar, and I'm surprised. Only 60 millimeter precipitation makes the flood like this. Of course, it's a desert country, and they have enough evacuation of the rainwater flow. So that's why it occurred flood like this. But normally, we can't see the flood in a desert country like this. So it's a very rare case. And also we got a very heavy storm in Japan too. Almost every year recently. This is a sample of the 2018. The very heavy rain cloud is passing through all over Japan, and we got this precipitation over 500 millimeter, 3 days or something. And like this, big flood. It's the effect of the climate change in the short term. So we have to control the climate change, and this is a strategy against climate change. At first, the control of the carbon dioxide emission. For this purpose, we have to restrict the fossil fuel consumption. For this purpose, some renewable energy will be provided instead of the fossil fuel. Normally, we have to change the fossil fuel to carbon-free or carbon-neutral energy. Carbon-free is, for example, solar power or wind turbines, and carbon-neutral is biomass energy is called carbon-neutral. And also, we have to reduce the energy using or energy consumption itself. That is energy saving. And finally, we have to think about the carbon sink. That means just directly, we have to capture the carbon dioxide in the atmosphere and blow it into the earth, or sometimes we have to grow the forest to absorb the carbon dioxide. This is the carbon sink. So this point, we have to talk about the ZEB. Now, what is the ZEB? So ZEB means net zero energy building. So net means sometimes the energy supply and the energy generation is moving like this. And selling energy and buying energy is changing gradually. So totally, if we sum up the total energy in a year, the consumption and generation is zero or plus. That is called zero energy. And we have to think about the total energy of 1 year. That's why we attach the net at the head. Actually, it is net zero energy buildings, but normally we call it ZEB, ZEB. So this point, if you studying about green buildings or something, it's a very good topic for you. We have to consider the energy consumption in the buildings. And the building energy is like this. Not include something like very special devices in the building. These 5 categories of the energy is directly connected with the buildings. One is the air conditioning, and second, ventilation, third, lighting, fourth, hot water supply, and finally, elevator. Sometimes it's include the escalator, but anyway, the moving tools. So these 5 category of the energy consumption is counted for the ZEB. And the consumption and generation is positive or zero. That is called zero energy buildings. However, big generation beyond the big consumption, or small consumption and reasonable generation, which is better? I have to think about this very deeply. Please understand this. This photograph shows the mega solar power station. These PV modules, solar power modules, are generating a lot of electric power. And if it is used in small buildings like this, of course, maybe it's a zero energy. However, is it called a ZEB or not? So this is the point. At first, we need to reduce the consumption of the energy in the building, and reasonable energy should be generated and supplied, self-supply. So this is the real ZEB. And in Japanese government decided the definition of ZEB like this: net zero energy buildings defined in Japan. At first, high efficiency of energy use. That means energy savings. Over 50% of the normal building is reduced by energy saving this point. And after that, the over 50% is generated by the renewable energy and self-supplied. And the net zero is achieved. This is really called ZEB. So the basic concept of ZEB is at first energy saving system. And this is something like a Japanese system. It's something for the reference for you. But I have to mention about that. ZEB ready and near ZEB or ZEB is defined by Ministry of Environment Japan. So at first, just for the energy saving buildings, over 50% than standard building. And over 50% of energy saving plus self-energy supply over 25%, it is called near reserve. And finally, over 50% of self-energy supply, that is called ZEB with the energy saving. So always energy saving is the basic concept of ZEB. Recently, ZEB-oriented is added for the 3 categories and totally 4 steps of ZEB. And that is added in 2019, last year. That means 30 or 40 energy savings plus new technology to save the energy. I have to say that how to save the energy is one point. I mean that the Japanese government defined energy saving technology to calculate the energy saving ratio. However, there are much more new technology. Therefore, we have to test the new technology, and also we are allowed to save the energy by the conservative technology by 30% or 40%. 30 or 40% is defined by the purpose of the buildings. For example, the commercial buildings have to save 30%, and the office building have to save the 40% like this. So this is the building code of ZEB. It's a very legislative work, so not so interesting, but we have to understand what is ZEB. Basic theory of ZEB is saving energy, as I said before. However, there are no code or regulation for ZEB itself in the Japanese government. Usually, we are using the Act on the Rational Use of Energy. However, it's a very old one. It's different in it's established in 1979. That means it comes from the oil crisis. So mainly that is depend on the energy management for the transportation or industry and some parts of the big facility of buildings. However, the energy consumption in the buildings are a little bit different from the rational use of energy law. So that's why we have to change the something legislative background of the energy use. And 4 years ago, the new law about the energy, building energy efficiency was established. It's focused on just energy efficiency of buildings. And we have to consider the regions. As you know, Japan is very long for north-south direction. And northernmost part is Hokkaido. It's very cold place. And now I'm living in Okinawa, at the southernmost point of Japan. It's almost the same as Indonesia, a little bit different in the winter season, but in the almost 2/3 of the year, it's almost the same as Indonesia. So the wide range of the north or south regions. So we have to categorize the climate characteristics in 8 regions. But it's not for ZEB. This role was established not for ZEB, but just for energy efficiency. We have to consider the energy efficiency for the new building design or something. However, the Japanese government, especially METI is the Ministry of Economics, Trade and Industry, and the MOE, and the MLIT. MLIT is the Ministry of Land, Infrastructure, Transport, and Tourism. These 3 ministries are defined ZEB by themselves. So it is a national law, or not a law, but a national regulation of ZEB. So this is a rough sketch of the Building Energy Efficiency Act. We have to submit the energy performance of the buildings before construction. I mean that when the design stage, we have to submit the energy performance to the certain authority, and if they review the application, and it's good for the energy consumption, they allow to construct the building. If not, we need to change the design again. So anyway, they have to allow the construction of the building from the aspect of the energy consumption. But it's limited only for the total floor area of 2,000 and more. And the smaller buildings, including residential houses over 3,000 square meter and more, just for the submit the calculation of the energy consumption. It's just for submit, not reviewed. So non-residential buildings are called ZEB, or sometimes target of ZEB. And residential houses, it's not so popular, but that is called target of ZEH. We call it sometimes ZEH. So I'm talking about only ZEB here, non-residential buildings. And non-residential buildings is calculated its energy consumption by this part and this part or something. This red dotted line shows the surface of the buildings, the rooftop, highest floor of the buildings. It's just directly affected by the surrounding air. So, and also the 5 meter from the surface of the building, that is called perimeter zone. These perimeter zones are very important for the air conditioning system. This is calculated like this, per star or something. And also we have to calculate primary energy consumption for 1 year. Primary means the energy resource. I mean that we are consuming the electricity or some other energy in the building, but the primary energy is the resource of the electricity. For example, if we consume the 1 kilowatt hour of electricity, that is made from the oil or coal or some other fuels, maybe it's much more, sometimes 3 times as much more of the electricity. So that is primarily energy consumption. So I have to touch a little bit about the technology of ZEB. Normally, we have to consider the 5 types of the energy consumption in a building. And air conditioning system. If we think about the energy saving of the air conditioning, of course, we need the thermal insulation, wall or roof or glasses too, and the high efficient of air conditioning system. It's a mechanism itself. We have to use the higher performance of the compressor or something like that. And the ventilation. And ventilation is the electric fan itself. We cannot reduce the energy anymore. Or a new type of the motor control or something. But anyway, not so much reduced from the ordinary conservative style of the ventilation. However, it makes sometimes a big load for the air conditioning system. That's why we have to adapt the heat exchange type. If the outgoing air is air conditioned, controlled to the comfortable zone of the air temperature or something, so incoming air is the outdoor air. So if the incoming air is higher than the outgoing air, it makes the big cooling load. So that's why we can utilize the heat exchange type. And the lighting is not so difficult. It depends upon the makers of the lighting devices. Mainly, we depend upon LED, and sometimes we adapt the human sensor. If there are no human, no occupants, the light is automatically off. Looks like this. And hot water supply. Yeah, it's not so important for the ordinary office buildings, but it's very important for the hospital or commercial buildings or something like that. So that's why the hot water supply is one of the big point of the energy consumption. And recently we are utilizing the heat pump type or heat recovery type. Elevators are not so important for lower rise buildings, and so sometimes we need to use steps. However, the high-rise buildings is very important. But sometimes the elevator is moving by itself without the people or something, and it makes the sometimes energy by itself if it is going down. So we can recover the energy by the elevator. So the energy recovery type elevator is used. And also, how many people are waiting for the elevator is very important factor. The control program for the elevator system is also important. On the other hand, energy generation system for ZEB is another point. Normally, the solar power photovoltaic system is used for the energy generation for ZEB, but sometimes small wind turbines are used too. Not so ordinary case. It's very rare case, but wind turbines are sometimes used. So this is the technology of ZEB. Now, some scientists or engineers are developing the technology of ZEB much more. And this is the energy efficiency labeling system in Japan. We call it BELS. So BELS is what do you say? One category or one ruler for the ZEB. If the BELS is good, we can register the one building for ZEB. At first, one building, if someone want to register the ZEB, so we have to calculate BELS. BELS is one ranking system of building energy efficiency. The Building Energy Index, BEI. This BEI is used for the energy efficiency labeling system. Energy labeling system is dependent upon the standard buildings. Thus, how much the energy is reduced from the standard buildings, that is the BEI. So design buildings is lower than the standard buildings. The BEI is less than 1. And if this is 0.5 or under, that is the ZEB ready. So BELS is the ranking by BEI and the ZEB that is authorized by BELS. So if BEI is under 0.5, it is ZEB ready. And so I think that you have a question about the standard buildings or how to calculate the BEI. So Japanese authority, that is the Architectural Institute of Japan, they are developing the calculation program, and it is called WebPro. So WebPro means we can utilize the program by the internet. If we have input data of the calculation target building, we can utilize the WebPro through internet. It's free. It's free for calculation, so easy to use. Of course, that is provided by the Japanese government. That's why it's free. However, the WebPro is not so good name. I asked my friend in the Japanese Institute of Architecture. They say that not so good name for the program, just for call WebPro. So I asked them name it much more better one. So anyway, this is the authorized program to calculate BEI, and it is utilized for BELS. And the standard buildings for the BEI is automatically calculated inside of the program. So we don't care about the standard buildings. Just for the target buildings designed by ourselves, how to input the data to WebPro. So this is the labeling system. And ZEB is registered by this labeling system. Of course, we have to consider about the SDGs. So number 7, affordable and clean energy supply. And number 13, That is the climate change. This is the big target of the ZEB in the SDGs. And so I'm wondering that you are thinking about the price of ZEB. Of course, we have to attach the various technology of the energy saving system in the building. And if we design a bit ZEB, it's a little bit higher or expensive than ordinary buildings. Sometimes it's 1.3 times as or 1.5 times as the ordinary buildings. So the financial background of ZEB is very important. That's why we have to consider the investment. Investment for building is important thing. If it is right and reasonable of the stakeholders, we can invest a little bit higher money for building. That's why we need to think about ESG investment. If it is the public project, I mean that some government or municipalities or local government want to make a new buildings of energy savings, the resource of the money is the tax. So residential people are taxpayers. We have to make a very good what you say, inspection or sometimes the responsibility for the new buildings. That is the reasonable investment. If it is a private project, the owner has the big responsibility to invest money for the buildings. So anyway, the stakeholders are very important for ZEB. So this financial point of view, ESG is important for the new building project. ESG means environmental factor, social factor, and the governance factor too. Governance factor is a little bit different from ZEB, but environmental factor is a most important point of ZEB. And the social factor is also, ZEB has the social responsibility from now on against climate change. So ESG is another big point for ZEB. Normally, we have to only the technological side or engineering side of the buildings, but the higher price had reasonable point. I mean that if we invest a higher money, bigger money for the one project, it has a reasonable reason or something for the higher investment. That is the ESG investment. Normally, if we invest bigger money for ZEB, of course, the initial cost of the building is higher, but we don't have to pay any more after the construction completed because the energy is almost free. I mean that it's self-supply energy. So we can pay back by the reduction of the running cost. So how many years we need to pay back by the running cost for the initial cost? So it is a question. Normally, we have to design the buildings about 7 years or 8 years or so. This is the basic concept of ZEB. So thank you very much for your attention for my presentation. Okay, my presentation is over.
Thank you, Professor Tsutsumi. So it's very interesting presentation about energy in the building, and I think as Professor Tsutsumi has mentioned, construction is responsible for about 85% of the carbon dioxide.
Yes.
So we as an architect who design a building, so we also have a great responsibility on the climate change. Okay. Okay, so I would like to invite the question. There's a question from Satria in the chat. Satria, I think you can ask the question directly to Professor Tsutsumi, please.
Okay.
Okay. Thank you, Pak Edo. Professor Tsutsumi, my name is Satria.
Yeah. Hello.
Yes. I have a question. Actually, I have written it in the chat. Yes. Is there any other way to generate the energy in Japan besides using photovoltaic and wind turbine? Because I think that both ways, using PV or wind turbine, it could be implemented in the small house maybe. Yes. So I hope that there is a way, another cheaper technology maybe to be implemented, and especially in the house, in the small house. Yes, and I hope so. You can share about Z later. Maybe I just guess that ZEH is zero energy house maybe.
Yeah.
Okay, thank you. That's all.
Yeah, thank you for a good question. So I didn't see the chat. I'm sorry in my presentation time. Okay, I'll answer your question right now. So unfortunately, it's not so easy to find a good energy resource instead of solar power or wind power. And normally, real existing zero energy buildings or zero energy houses, they are all using just photovoltaic panels. And as you know, that the energy price by photovoltaic panels is not so cheap. Of course, we need to equip the some expensive panels on the rooftop or something. However, normally the energy price is recovered. I mean that it's gradually pay back the initial cost by the running cost. And finally, if only PV panels are used for the energy generation systems, maybe under 10 years, I mean that 7 or 8 years, it's enough to pay back. I'm sorry, it's just for the Japanese situation. The energy price in Indonesia, I'm not sure about that. But gradually, the photovoltaic panels are cheaper and cheaper. So I hope that it's better to use the PV panels much more easily. And the other possibility of the energy resource, for example, if you are living in Indonesia, maybe geothermal is one choice, but it's very limited place, not so everywhere. So other things, in a small island, sometimes we try to utilize the seawater just for the seawater thermal exchange. I mean that the temperature difference between the deep sea and surface sea or something, we can utilize it for the power generation. But sometimes it's very big system, not for a single unit house. As you say that the residential house maybe it's under 100 square meter or something. You try.
Tahu dia udah mulai.
Okay. Yeah. If you utilize the photovoltaic system for ZEH, it's completed already.
Udah.
Okay. Thank you.
Webinar.
Okay, thank you, Professor Tsutsumi. Okay, that's enough, Prof.
Okay, thank you.
Edward.
Satria, are there any other questions from the audience? You mentioned about bells in your presentation, Sensei.
Yeah.
So, as far as I know right now, Japan using CASB for calculating the sustainability index and green index formally, but I don't know, is it a change or something, or is the bells is more specific?
Yes.
Kind of
Yes.
like,
Yeah, thank you very much for your very important question. I have to mention about the difference between CASB and BERS. So BERS is the total environmental, registration or something regulation system. It includes a much more wider range of the environment factors. Not only the energy consumption, but it's include the, for example, noise control or color or surrounding area or waste management or such a things. So very wide range. And if we consider or if we utilize the CASB for ordinary buildings, very big power. I mean that the human resource is so big and difficult to apply it. So that's why the BERS is another one. I mean that it's only used for the energy consumption. So just focus on the energy system. So it's easier to calculate the BERS or Webflow or Bay. So that's why BERS is newly developed, entirely apart from the CASB system.
So it's complementing the CASB.
Yes.
So it's more specific only for the energy consumption.
Yes.
For the bells. Okay. So what about in Japan condition right now, according to your experience? So you mentioned about ZEB ready, nearly ZEB, or already ZEB. So if we make a percentage of the whole building in Japan, so how many buildings already implementing ZEB or nearly ZEB or ZEB ready? Or so
not exactly, but just in Okinawa, already 40 buildings, over 40 buildings are registered as ZEB.
40 buildings.
Yes. And so a part of them, 4 buildings are registered as the real ZEB, and several parts are just for ZEB ready or something. But totally, including ZEB ready, nearly ZEB, and ZEB, totally about 40. And so total Japan, I don't know, already over 10,000 or something. Not so difficult. Hello?
Sorry, I think I lost my connection recently.
So I'm sorry. Okay.
Okay.
So total Japan, we have already 10,000 over. So I
10,000.
cannot count it anymore.
So there's already a lot of building using this index, building energy index through bells. So it's very nice. Mm. Okay, are there any?
One question from Yayuka?
Yayu? Who are you? Please.
Yeah. Yeah, I do. Thank you.
Yeah.
Yeah, may I have a question from Prof. Tsutsumi?
Yes.
How is if the building is already exists and how to set the implementation of the system to zero waste? After the building is already exists, is it possible? It's more expensive than when we can set it from the beginning. What's your opinion about it? Thank you.
Okay. Yes, it's possible. And sometimes we adopt the ESCO project. ESCO means ESCO. ESCO is something like the implementation system of the renewal of energy system of a building. For example, 20 or 30 years passed after the compression of the building, almost all the building system, including air conditioning or lighting or water supply or something, they are old one, and sometimes it's low efficiency. So if it is changed to be a new technology, the energy consumption was drastically changed. So we can reduce the running cost or running energy. So that's why this system adapted for the existing buildings. And for example, if we invest the money for the renewable of the old buildings, so we can reduce the energy price. And if we can reduce the energy price, we can pay back the investment for the renewal of the buildings. This type of the project is called ESCO, ESCO. So this is the one technology of the ZEB. So it's also the financial system to renew the building. Yes.
Okay.
And also I need to add the information about the support money from the government. If we want to adapt the new technology or like a ESCO's project, the government supports the money, a part of the money, 1/3 or a quarter of the total investment that was supported by the government. Yes.
Okay. Thank you.
Yeah, thank you.
Thank you, Baido.
Yeah, thank you, Bu Yayu. Yeah. When I was in Japan, I learned about cash fee a little bit. So there's also a cash fee for residential, non-residential, also for the already built building or newly built. So also for the bells, also they have such kind of a calculation system also for the newly built and so the already built buildings will have a different kind of calculation.
Yep.
Okay. So any other questions from the audience?
Okay.
No. Okay, from me, another question. So, As far as I saw in your presentation, the approach of ZEB is more from the solution of active design, which is using appliances or features or some kind of thing like that. So are there also any encouragement of approach which is using a passive design solution toward the building, which is especially for the newly designed building? Are they also the architect or the developer of the building also encouraged to use a passive design approach for their new building?
Yeah, it's a very good question. Yeah, and the answer is so difficult. Unfortunately, not so much, because that I said that the BERS system is depend upon the web flow, the program to calculate the energy efficiency provided by the Japanese government. The program is very good one, but not so correctly working. I mean that very small detailed design of the building itself is not input to the web flow. For example, if you utilize the louver to control the solar radiation or something, it's impossible in the web flow. And if you make wrong eaves or something like that, also it's very difficult to utilize it in a web pro. So normally we can consider the passive design in web flow only the solar, heat insulation or sometimes the size of the windows. Not so much. And I'm asking my friend who is main person to develop the web flow, we need to make a much more correct design inside of the program. But he said, okay, I'll try to do that. Maybe in several years, they can make a much more precise program for calculation of the building energy.
So it's developing and getting more and more better in the future, I think. It's very nice. Okay. Are there any questions from other students? So we have not only the doctoral students, but also master and bachelor students joining us at this moment, Sensei. Okay, so also it's already past the time, and before we close this session, so I would like for the audience to turn on the camera, and we will take a photo session for today's event. So would you please turn the camera on? Hello. Pak Satria, when we are ready, please take the picture. Okay.
Okay. Okay.
Hello.
I'm still waiting.
Yeah. Farah, Fitri, Syahda, Purnama, Mistrina, maybe they are sleeping. Teguh, Mr. Mardwi, are you with us?
Okay.
Okay. I think my internet connection is not stable. So, Pak Satria, please take the picture whenever it's ready.
Yes. Okay. I think it's enough, Pak Edu. I will
Okay.
take the picture. I'll count to
Okay.
3. 1, 2, 3.
Okay. Another
Okay.
one. Freestyle.
1, 2, 3. Yes, it's enough. Thank
Okay.
you.
Okay, thank you.
Okay, thank you very much again to Professor Tsutsumi, who already provide his time and knowledge to us today and sharing about zero energy building. So as Satria has asked that maybe next time and next occasion, Professor Tsutsumi could share with us about zero energy house. Maybe I wonder the difference between zero energy building and zero energy house for the residential. Yeah, I think in Indonesia, as far as I know, we're still developing, and one of the tools for calculating the include the energy is the Green Building Index, which is used to rate the energy efficiency of the building, which is built in here in Indonesia. Okay, I think that's all that we can do for today. Again, thank you, Professor Tsutsumi. I would like us to give applause to Professor Tsutsumi. Big applause for Professor Tsutsumi, and thank you very much for being with us today. And thank you also for the all the audience, all the students and lecturers who already joined with us today. I believe that what we have learned today from Professor Tsutsumi could give benefit to all of us. Okay, thank you again, Professor Tsutsumi. See you next time. We will have a discussion on Friday.
Okay, I see.
Okay, thank you.